Okay, this lesson is on rational exponents. Rational exponents are fractional exponents. For example, 3 to the 1/2 power. Now if I square that, and using my properties of exponents, in a situation like that, I'm supposed to multiply my exponents together. That's 3 to the 1/2 times 2. That's 3 to the 1st power. That's just equal to 3. Now if I compare that to the square root of 3 squared, that means square root 3 times square root 3, and that also is just equal to 3. Now if this squared equals 3, and this squared equals 3, then it seems that 3 to the 1/2 power has to really be the same value as square root 3. And that actually is the case. A 1/2 power means square root. Let's put this on the side. A to the 1/2 power actually means, as a radical, the square root of A. Likewise, if I had A to the 1/3 power, that actually means cube root A. And in general, A to the 1 over n means the nth root of A, as long as n is a whole number 2 or larger, for n greater than or equal to 2, an integer. Some examples of that. For instance, 9 to the 1/2 power means the square root of 9, and that is equal to 3. 25 to the 1/2 power is the square root of 25, which is 5. 8 to the 1/3 power, according to our property we have up there, is the cube root of 8, and the cube root of 8 is 2. 16 to the 1/4 power, that means the 4th root of 16, and that also is a 2. Here's some more. 36 to the 1/2 power means the square root of 36, which is 6. Negative 36 to the 1/2 power. Notice the negative sign is not in parentheses, so actually what this means is negative 1 times 36 to the 1/2. That's negative 1 times the square root of 36. So this is going to give me a negative 1 times 6, negative 6. Compare that to this one, negative 36 in parentheses to the 1/2. Now since the negative sign is in parentheses, this is, as a radical, the square root of negative 36. And as we talked about in a previous section, you can't take the square root of a negative number. This is not a real number. However, I can have something like this. Negative 27 to the 1/3 power means the cube root of negative 27. And we can take cube roots of negative numbers. This is negative 3. Compared to this, we end up with, actually let me write that down below, I'm running out of room here. Negative 27 to the 1/3. That actually means negative 1 times 27 to the 1/3, which is negative 1 times cube root 27, negative 1 times 3. This one also gives me negative 3, but the work is slightly different. One over 32 to the 1/5 power. That means the 5th root of the fraction 1 over 32. And what number, when you raise it to the 5th power, gives you 1 over 32? It is 1/2. 1/2 to the 5th power is 1 over 32. Okay. Now, if we have, for instance, 9 to the 3/2 power, well, what I can do is think of it this way. That's 9 to the 1/2, and then cubed. After all, if I multiply these exponents together, that does give me 3/2. But from what we just learned, 9 to the 1/2 is actually square root 9 cubed. The square root of 9 is 3, and that cubed gives me 27. And so really what we're going to do here is we're going to have this number, this 3 up here, and this 2 is actually the root right there. The rule looks like this. A to the n over m, let's make that m over n, yeah, your book does it backwards. A to the m over n is equal to the nth root of a to the m power. Or you can actually have the m inside if you want. Let's fix that. Nth root of a to the m. Let's do some examples of that. For instance, 64 to the 2/3 power. According to this rule, 64 to the 2/3 is the cube root of 64, and then you square it. The cube root of 64 is 4, and when you square that, you get 16. 10 to the 3/2, according to this rule here, this is the square root of the second root of 100, and then raised to the 3rd power. Notice that this number here is that, and this 2 here is the index. The square root of 100 is 10, and then when we cube that 10, we get 1,000. 4 to the 5/2. Excuse me. Okay, according to our rule, this is the same as the square root of 4 raised to the 5th power. The square root of 4 is 2. Raised to the 5th power is 32. Negative 16 to the 3/4. Remember that the negative sign here is not in parentheses, so it actually means negative 1 times 16 to the 3/4. This is negative 1 times 16 to the 3/4 power is the 4th root of 16 cubed. The 3 is here, and the 4 is right there. This is negative 1. The 4th root of 16 is 2. You've got to cube it, though. Negative 1 times 8, negative 8. Let's compare this problem to negative 16 in parentheses to the 3/4. Since the whole thing is in parentheses, it's going to go under the radical sign. This is the 4th root of negative 16, and then cubed. Recalling a previous section, we cannot take the 4th root of a negative number, and so this is not a real number. Okay. What about 16 to the negative 3/4? Well, we have to recall what a negative exponent is. If you remember, if I have, for instance, put on the side here, if I have 2 to the negative 3, to make that exponent positive, I use the reciprocal. This is 1 over 2 to the positive 3. Same thing here. 16 to the negative 3/4. To make the exponent positive, I flip it over. It's 1 over 16 now to the positive 3/4 power. That is 1 over 4th root of 16 cubed, which is 1 over 2 cubed, and that my answer is 1/8. Here's some more of those. 36 to the negative 3/2. To make the exponent positive, I write this as 1 over 36 to the positive 3/2, which is 1 over, as a radical, this is the square root of 36 raised to the 3rd power. square root of 36 is 6. And when I cube that, I get 1 over 216. 1 over 216. (32 to the negative 4/5) is 1 over 32 to the positive 4/5 power. 1 over, as a radical, this is the 5th root of 32 raised to the 4th power. The 5th root of 32 is a 2. This is 1 over 2 to the 4th, which is 1 over 16. One more of these. 4/9 to the negative 5/2. To make the exponent positive, we flip over the fraction, so this is 9/4 now to the positive 5/2 power. Writing it now as a radical, this is the square root of 9/4, square root, and then I'm going to raise that to the 5th power. Okay, the 5 is here, and then the 2 is right there, the index. Now the square root of 9 over 4 is 3 over 2. And then we raise that to the 5th power, and that gives us 243. 3 to the 5th is 243 over 2 to the 5th, 32. Good. Moving on. Write as a radical. (5 to the 2/3). As a radical is the cube root of 5 squared. Or if you want, you could put the square inside. That's the cube root of 5 squared, which is the cube root of 25. Either one of these is correct. Any one of those. 4k to the 3/5 power. Now notice that there's no parentheses, so 4 is on the outside. This is 4 times k to the 3/5. 4 times k to the 3/5 as a radical is the 5th root of k to the 3rd power. You could put the 3rd power on the outside or inside, like that, or 4 5th root k cubed. The cube can go inside or outside. 7x in parentheses to the 4/3. Now because we have parentheses, everything in the parentheses is going to be under the radical. This is going to be a cube root, because of this 3, cube root, 7x, and then that's to the 4th power. Just like that. And that is our part 1 of our rational exponents. Coming up is part 2.